Hello and welcome to Train Signal. You are watching Managing System and Kernel Logs. During most of my tenure as a network administrator, I was fortunate enough to always have a team of incredibly smart folks to work with. At one job, however, I was the lone wolf. I was responsible for building and supporting an entire Novell network by myself. A daunting prospect at the time, I admit it was a period in my career when learning through trial and error, my knowledge increased exponentially. Thankfully, that was a long time ago, but one thing that I remember is that even in that environment, it was easy to put off or overlook system maintenance duties. Linux log files can be huge, and perusing these files is really no small task. Yet it's critical, especially today with the myriad of security threats ever looming, that you don't ignore this data. Linux has many log files that are used to provide you key details about how your system is operating. Most of them are readily available, and you don't have to do anything but dig in and start reading. But eventually, you'll need to dig a little deeper, and for that, you need a sound understanding of how Linux manages log files. So in this lesson, we'll talk about the syslog daemon, syslog-d, and how it functions and manages server and program messages. Then we'll cover how to modify and configure syslog. Next, we'll review manual logs and the important task of log file rotation. And finally, we'll talk about the different command line methods to view your system log files. Let's start off with a look at syslog-d. The Linux system generates its own log files, then some programs generate them as well. What you end up with is an extremely large number of files that, left to manage individually, could become, well, unmanageable. A system logger provides a centralized method to handle log files. Syslog-d is a daemon, which as we know runs in the background, and it takes data from servers and programs that are set up to use it. It acts sort of like a traffic cop, directing the data to the appropriate log file. Like other daemons that we've talked about, syslog-d is configured through a file stored in the etc directory, and it's called syslog.conf. Though Fedora uses rsyslog.conf. The format for lines in the config file are facility.priority followed by action. Facility is the type of program, and priority is a code for the importance of the message. An action is a file, a remote computer, or another location that should accept the message. The facility and priority portion of the line is known as the selector. Let's take a look at the options on the next slide. Okay, so we know that the syslog-d configuration line format is facility.priority followed by action. But we need to know what parameters can be included in this format. The first part, facility, has the following options: auth, auth, authpriv, corn, daemon, kern, lpr, mail, mark, news, and we have security, and we have syslog, user, uucp, and finally local 10 to local 17. Now some of these are easy to recognize, like LPR for printer, mail for mail, then you have syslog, but the rest of them might look a little unusual, and most of these are just servers or programs. Now daemon is often used when a program doesn't have a specific code. Next is priority, which again together with facility make up what's called a selector. Its options are debug, info, notice, warning, warn, error, and its identical counterpart ERR. Next we have crit, alert, emerge, and panic. Also, warning and warn are equivalents, as well as emerge and panic. Now at last check, error, warn, WARN, and panic were deprecated, but this may vary depending on your distribution. And finally we have the action, which is usually a file name in var log, and it could be messages, syslog, secure, or some of the others, which include console, remote PC, users, and asterisk, which again means all. Let's open a terminal window and check out our own syslog file. From the main menu, Click on Applications, System Tools, and Terminal. First, let's make sure that we have the daemon running, which we probably should. But let's type in ls space etc init.d and hit enter. And what we have is our syslog. Again, because our test system is Fedora, the configuration file is a little different. Normally you would just see syslog here. Now let's take a look at the configuration file. So let's go ahead and type in cat space /etc, and we know the name of our file is our syslog. Again, on your system it could be just syslog. .conf and hit enter. Let's scroll up to the top of the file, and as you can see we have a couple comments here to lead off, and then we have the module section which outlines some kernel and messaging directives that we see here. And again, we see the lines are in the format. If we go down here and look at the global directives and rules, we can see that the lines are in the format facility, dot priority, or the selector, followed by the action. Let's scroll down. So in this line, for instance, this says to log all mail messages in one place. So we've got the mail facility, followed by the dot, followed by the priority, which is all, and then it says to log all of those in var log mail log. And if you look here, we also have a line for cron, and this basically says to where to log the cron files. And again, we have the facility, which is cron, followed by the period, followed by the priority, which is all, and it says to log those in var log cron. And our file ends here. A couple more settings, and we've got some comments to document the other file settings. Normally Linux handles log files admirably all on its own, but there may be times when you need to generate something special. For this purpose, you use the logger tool. The command syntax is logger space options space message. The message field is normally whatever you specify after the options. And this can also be input from the command line. Logger takes several options, and they include first, -i, which records the process ID along with the log message, -s, which echoes data to standard error in addition to the log file. Now if you remember from our GNU and Unix commands lesson, we learned that standard error, which is denoted with the redirection operator to and the greater than sign, is used to redirect standard error. And we also learned that a common trick to get rid of data like unwanted error messages is to redirect that data to dev null. Moving on, we have next-d, which uses a datagram rather than a stream connection to logger socket. Now this is an advanced feature that you should use with caution. Typically you'll only use it if documentation for a specific program tells you to do so. -f space file logs the contents of a file. -p sets a priority. -t removes the logger tag from file names, since it's normally included by default. And finally -u logs directly to a network socket. Let's head back to our terminal and try out the logger command next. Okay, let's go ahead and clear our screen with clear. Now, say that we wanted to log a message as a reminder for ourselves. We know that if we use logger with no options, the last field is considered a message. So let's start out by typing in logger space, and I'm going to make the message testing log settings and hit enter. Now this note is probably going to get logged in var log messages. So let's take a look at the log file to see if our message appears. Let's type in cat space var log messages. We forgot to obtain root privileges, so let's do that first. Let's type in SU and our password. Now let's try. Cat space var log messages. And hit enter. Now this will go through a long list of log entries, but as you can see here, our last one has indeed been picked up, testing log settings. Now let's try the -F file option to log the contents of a file. Now let's use one of the script files that we created in our previous lesson. I'm going to use case demo. Now with this option, you don't really want to use a large file, as that would in turn increase the size of your log. We always want to keep our log file sizes under control. So let's type in logger space -F, and again I'm going to use case demo.txt. Just use a file of your choice and hit enter. Now let's go ahead and hit the up arrow key so we can bring up the cat command again and hit enter. And as we can see, the contents of that file have indeed been added to the end of our log file. Now let's go back to our presentation and talk about rotating log files. Because syslog has no built-in mechanism to control the size of log files, they can quickly grow and expand. And in a world where enterprise hard disk space needs to be tightly controlled, it's important to employ some level of, control. Linux lends a helping hand with log file rotation tools. They can rename, compress, delete, and even force creation of new log files. The most popular tool is called log rotate. And we first got a glimpse of this program when we talked about cron jobs in our job scheduling lesson. That's because, if you recall, log rotate is one of the programs controlled by a cron job. Can you tell me where log rotate's configuration file is stored? That's right, in etc. You should be seeing a pattern there as well. Configuration files will normally sit in the etc directory. A sample logrotate.conf configuration file is on your screen. It starts out with some comments, followed by individual directives like weekly, rotate, create, etc. Let's go over to our terminal window and take a look at a live configuration file. I've already cleared our window, so let's type in cat space etc log rotate.conf and hit enter. Let's scroll back up to the top. You can see again that we start off with a couple comments indicated with the pound sign. Then we've got a weekly directive, which says to rotate the log files weekly. We've got create, got a date directive, and if we scroll down a little bit, if you take a look at this line right here, it indicates that you should look for files for RPM log files in the etc logrotate.d directory. We'll talk about that a little bit more in just a moment. But this is the directory where you store individual log files. Then we've got some individual packages here, WTMP and BTMP, with their own settings and directives that again will be overridden by anything that's in the default settings. And we've got a last line here with the comment that says any system-specific logs can also be configured here. Now let's go back to the presentation and review this file format in a little more detail. So we review the logrotate.conf file and understand the settings there, and we also learn that files for individual packages are also stored in logrotate.d. The format for files in this directory is file name, followed by an opening curly brace, then you have some options, then a closing curly brace. Let's take a closer look at these options on the next slide. We looked at the format for the definition of a specific log file entry on the last screen. I should note that these settings will override the default log file settings. Now they have some options that we should review, and most are fairly simple. The first is date.ext, which uses a date code instead of the default numbering scheme, which is usually .1, .2, .3, and so on. Next, compress CMD is used to indicate a different compression tool, as gzip is the default. Now this is useful if, for instance, you want to use bzip or another zip tool. Create does just what the name suggests and is used to create a new log file. Time is used to set up the log rotate interval, and that's daily, weekly, or monthly. Size will set the maximum file size for the log file, and X sets the number of old copies to be maintained. Mail says where to email a log file when it's rotated out of existence, and by contrast, no mail says not to send any email at all, my preferred option. Pre-rotate and post-rotate specify scripts to be run before or after log rotation, and all scripts must end with the keyword InScript. Let's go take a look at logrotate.d. Okay, let's type in ls space etc logrotate.d and hit enter. We can see a listing of all the files that are in the directory. So let's take a look at the yum file. And we know that yum is the Red Hat derivative command line package installer. So let's type in cat space etc logrotate.d/yum and hit enter. Okay, some of the options that you should recognize are file size, which is set for 30K, rotation is set to occur yearly, and it creates a file called root. Now let's take a look at the man page for logrotate. Type in man space logrotate. I always like to check the man page because it gives you the most detailed version of all the options. Again, you can page down to look at all the content and study some examples and other things in more detail. Again, to exit man, you hit Q. And remember that you can do the same thing with info just by typing info followed by the command name. Now we know which daemon controls system logs, we know how to configure that daemon, how to manually log data, and how to handle log file rotation. But we also need to study our log files. We've used many of these techniques previously, those that we covered in our GNU and Unix commands lesson. So this should serve as a nice review and reinforcement exercise. First we have the pager or less command, which is used to display data in one-page increments. Then we have grep, which searches for a string in a file. Head and tail are used to view the first 10 and last 10 lines of a file respectively. And with the -F option, it continues to monitor the file and displays new lines as they're added to the file. And finally, there are third-party programs like logcheck that can also help. Let's go back to our terminal and try these out again. First, let's try the less command. So type in less space var log messages and hit enter. And again, it gave us one page worth of data. And you could enter to go forward one line at a time or page down to do page at a time. And to exit this view, we hit Q. Now let's type in grep so that we can search for a string in a file. Let's type in grep space and let's type in our login. We're going to look in var log messages again and hit enter. If there were any occurrences of our logon in the file, they would have appeared. Let's try another one. We'll type in grep, then we'll type in ETH0, which is the Ethernet connection, see if there's anything listed for that. And hit enter. And we do have some hits on that string. Again, it'll go through, search through the entire log file and bring up everything that has ETH0 in that line. Now let's try the tail command. And tail again will give us the last 10 lines of the log file. This is useful, of course, for if you want to see something that happened perhaps since you logged into the computer or since you rebooted. So let's type in tail var log and messages. And hit enter. And this will give us the last 10 lines, which actually includes things that we did earlier in the lesson. Now let's try the same thing with the -F option. I use the up arrow key to bring the command back up, and I'm just going to add in -F and hit enter. Again, -F will display the last 10 lines of the file, and if any additional data is logged to the log file, it will display that on the screen as well. Let's go ahead and launch another terminal window. Let's type in logger. This is a test. And hit enter. And if you go back over here, you can see that our log file was updated with the most recent entry. I'm going to exit out of this one. Now, log files will be one of your most valuable troubleshooting tools, and that's because if something goes wrong with the kernel or service, you can bet it will be logged. And that concludes our lesson on managing system and kernel logs. Let's go back to the presentation to review what we've learned. Reviewing log files may not be the most thrilling of exercises, but it is one that is central to the role of every Linux administrator. So understanding how to handle the configuration, management, and review of log files will ensure that you are always keenly aware of the status of your network and its programs. Don't overlook the importance of this task. In this lesson, we learned about the syslog daemon and how to configure log file settings. Next, we talked about manual logging and saw how to create our own log file entries. Then we moved on to log file rotation, the critical process of determining how and at what frequency log files are stored and removed. We finished up with a look at different tools and techniques for the times that I'm sure you'll set aside to view your own log files. Thanks for watching, and I'll see you in the next lesson.